This video is on integration using residues. In today's video, we are going to evaluate the integral using residues. So, evaluation of contour integration of integral 0 to 2 pi d theta by 2 minus sine theta. See, in the solution, first of all, we have to put, in order to solve this, we have to put z is equal to e power I theta. And see, what is e power I theta? This is cos theta plus I sin theta. Now, if I take modulus on both sides, mod z is equal to modulus of cos theta plus this value is I sin theta. Mod z value is equal to, this is root over cos square theta plus sin square theta. So which is equal to 1. So we got the contour as a unit circle. So it is a circle with center 0 and radius 1. And the next thing we have to calculate is d theta. As you know that z is equal to, so I am writing here, z is equal to e power I theta, and if I make a derivative on both sides, dz value is equal to e power I theta into I times of d theta. So e power I theta is equal to z. So dz is equal to zi into d theta. Therefore, d theta, we need the value of d theta in order to substitute here. So d theta is equal to dz by. So this is dz by zi. And next thing what we need is sine theta. Sine theta. How we'll get sine theta? So sine theta can be written as e power I theta minus e power minus I theta by 2i. And this can be written as sine theta is equal to z minus z inverse by 2i. So sine theta is equal to, so sine theta is equal to z minus, this is 1 by z by 2i. So sine theta value is equal to z square minus 1 by, this is 2zi. So if I bring it to the denominator, it will be 2zi. And therefore we got sine theta, d theta, and everything is ready. And now we are going to calculate this. So for calculating, as we know that d theta value is ready as, what is our d theta value? Dz by zi. Dz by, this is zi. And sine theta value is also ready as z square minus 1 by 2zi. That is z square minus 1 by, this is 2zi. And our contour is an unit circle. So center 0 and radius 1. Now what is our integral value? So this is our integral value. Now our integral value is ready as integral 0 to 2 pi. This is d theta by 2 minus sine theta. Now if I substitute here all the values, that is integral 0 to 2 pi. What is d theta? D theta is nothing but dz by zi. Dz by, this is zi by 2 minus sine theta value is nothing but z square minus 1 by, this is 2zi. Clear? Now this will be integral 0 to 2 pi. This is dz by. So if I bring it down, this is zi. And see, if I take 2zi as LCM here, this will be 4zi. This is 4zi minus z square. This is minus z square and this is plus 1. So if I cancel this zi, and send this 2 to the numerator, then this will be integral 0 to 2 pi 2 into dz by, this value is 4zi minus z square plus 1. Clear? So I want to make this z square positive. So see here, I am taking minus common. This will be z square minus 4zi minus 1. Clear? So the value here is integral 0 to 2 pi minus 2z by, this value is z square minus 4zi minus 1. Therefore, our integral 0 to 2 pi d theta by 2 minus sine theta I transformed like this. So here this is integral f of z into dz. Then what is our f of z? So our f of z value is very clear as So this is minus 2 by z square minus 4zi minus 1 is our f of z value. So in order to find the poles, we have to equate the denominator to 0. So if I equate the denominator to 0, see here, this will be z square minus 4zi minus 1 is equal to 0. So if I equate the denominator to 0, so this is the case. And see, z square minus 4zi. So f of z is equal to 0. So our z value is equal to, I am writing the formula here. So the formula is also minus b plus or minus. So this is nothing but minus b plus or minus root over b square minus 4ac by 2a. So this value is a, this value is b, and this is a c. And see here, our value will be minus b. Our z value is minus b plus, sorry, 4i plus or minus root over b square, that is minus 4i whole square minus 4 into 1 into minus 1. So this will be plus 1 by 2a. So 2 into 1. So here this will be 4i plus or minus, this value is a 16. I square value is minus 1 plus 4 by 2. Clear? And therefore this will be 4i plus or minus root over minus 12 by 2. So I am finding the poles here. So this is 4i plus or minus root 4 into, so this is 3, for minus 1 this is I square by 2. So 4, if I send it outside, see here, this will be 4i plus or minus 2 into I, this is root 3 by 2. So if I take 2 common, if I take 2 common here, then this will be 2i plus this value is root 3i by 2. So this is plus or minus by 2. So if I cancel these two, so we got the two roots. The first, so if I take 2 I common, this will be 2 plus or minus root 3. So 2 plus or minus root 3. And therefore if I consider alpha and beta as two roots, so alpha comma beta be two poles here, so two poles, then I am considering alpha as I times of, this is 2 plus root 3, and beta value as I times of, this is 2 minus root 3. See, clear? This is 2 plus root 3 and this is 2 minus root 3. So if you observe properly, so we have a circle. It is a unit circle, that is mod z is equal to 1. So if you see here, clearly our contour is a circle with center 0 and radius 1. Mod z is equal to 1. Here this will be the value. So this will be the value. It is 0. So this is the circle. So this is minus 1. This is plus 1, minus 1. This is minus I, and this value is plus I. So we have to check whether these poles are within the circle or on the circle or outside the circle. So here if you observe this one, root 3 value is 1.73. So this value is 1.732 something. So this is beyond, this is 3.732, which is greater than 1. So alpha value is greater than 1. So in this case, this is 2 minus 1.732, which is less than 1. So beta value is less than 1. So beta lies so within the circle and alpha lies outside the circle. Therefore, we have to find out the residue for this inside pole, interior pole. For finding residue, so first of all, I am transforming this f of z. So what is our f of z value? So here I have done here. So our f of z value is nothing but minus 2 by z square minus 4zi minus 1. So this is minus 2 by z square minus 4zi. This is minus 4zi minus 1. So I have to find the residue for the point, for the pole value beta is equal to 1. For this, f of z value can be written as, so f of z can be written as minus 2 by, this value is z square minus, this is 4i into z, this is minus 1. As you know that alpha value is nothing but alpha. So what is our alpha value? Alpha value is nothing but I times of, this is 2 plus root 3, and beta value is equal to I times of, this is 2 minus root 3. If I add these two, alpha plus beta, if I take I common, this will be 2 plus root 3 plus this is 2 minus root 3. If I cancel this one, this value is 4i. So alpha plus beta value is equal to 4i. So if I multiply product of the poles, that is alpha beta, alpha is equal to I times of this is 2 plus root 3 and this is I times of 2 minus root 3. I into I is I square and this is 4 minus 3. I square is minus 1. This is 4 minus 3 value is minus 1. So we got alpha beta value as minus 1. And therefore here see alpha and beta value is 4i. Clear? And plus alpha beta value is minus 1. So I can write here as alpha beta in place of 4i as alpha plus beta. So f of z value is equal to minus 2 pi. This is z square minus this is alpha plus beta value is 4i and z, and see minus 1 value I am writing is alpha beta. Clear? So this will be minus 2 by this is z square minus z alpha minus z beta plus alpha beta plus alpha and beta. And if I take z common from this, so f of z value will be, so f of z value will be this is minus 2 times of, from these if I take z common, this will be z minus alpha. So if I take minus beta common, this will be z minus alpha again. So alpha z minus alpha if I take common, so f of z value is equal to this is minus 2 by z minus alpha into z minus beta. So this is our f of z value. So now we have to find out the residue value, the residue of f of z. Residue of f of z at z is equal to beta. So this will be limit z tends to beta, z minus beta into f of z. Clear? So I am going to substitute as this value is limit z tends to beta. This is z minus beta into what is our f of z value here? This is minus 2 by z minus alpha into this is z minus beta. So if I cancel this z minus beta and substitute beta in place of z, this will be 2 by this is beta minus alpha. So this is our residue value. So this is minus 2 by what is our beta value? So beta value is also clear here as minus 2 minus root 3 I times of. So I am taking I common. This is 2 minus root 3 minus this is 2 plus root 3. So this value will be minus 2 by I times of 2 minus root 3 minus 2 minus root 3. So if I cancel these two and see, so this will be minus 2 by minus 2 root 3 into I. So if I cancel minus 2, this will be 1 by root 3 into I. So this is nothing but residue of f of z at the interior pore z is equal to beta. Now according to our residue theorem, so what is our residue theorem states? According to our residue theorem, so integral f of z dz is nothing but this is 2 pi I times of sum of the residues at interior poles. So the interior pole here is beta. So that is 2 pi I into 1 by root 3 into I. So if I cancel this root 3, so this will be 2 pi by 3. So what is our integral value? So our integral value is nothing but integral 0 to 2 pi d theta by 2 minus a sine theta value is equal to this is 2 pi by root 3. So this is how we have to solve. So this is also so simple if you follow this step, and let me explain you once again. So this is our final answer. See, let me explain you. First of all, what is the question given? We have to evaluate by contour integration, that is integral 0 to 2 pi d theta by 2 minus sine theta. So z is equal to e power I theta. E power I theta is nothing but cos theta plus I sin theta. Mod z is equal to cos square theta plus I sin square theta, which is equal to 1. So we got this. It is a circle with center 0 and radius 1. And again we need d theta value. For finding d theta, z is equal to e power I theta, dz is equal to e power I theta into I into d theta, dz is equal to z I d theta. D theta is equal to dz by zi. So sin theta value also we got like this. So every value we got and we are going to substitute here. So all the three values are ready and this is from the question. So in place of d theta I wrote dz by zi. In place of sin theta I wrote as z square minus 1 by 2 zi. So and after taking LCM and bringing ZI common. So this is the case we got, and this is how we got f of z. So integral f of z into dz. So f of z value is nothing but minus 2 by z square minus 4zi minus 1. So I have taken the pole values. So I have to equate this. In order to get the pole values, I have to equate the denominator to 0. Here I have equated and I got the pole values as, so here are the pole values, that is I times of plus or minus 2 plus root 3. So alpha beta are the two poles. Alpha is this one and beta is this one. So clearly we have this one. We have the contour as the circle value, the circle. So we have to check whether these two are inside or on or within the circle or outside the circle. So this is 2 plus 1.732 is a root 3 value. So this is outside. So alpha value is outside the circle and beta value is within. So the pole is within this one. So beta value lies within the given region and therefore f of z value is this one, and I can transform this as alpha is this one, beta is this one. So if I add up these two, this is 4i, and if I multiply these poles, it is minus 1. So in place of 4i I wrote alpha plus beta, in place of minus 1 I wrote alpha beta, and taking everything common. So I got f of z as this. So beta is our interior pole and therefore we have to find the residue for this. So this is the formula, that is limit z tends to beta, z minus beta into f of z. So after cancelling this one and substituting z value as beta, so beta minus alpha. So after cancellation, so we got root 3i. So according to our residue theorem, so 2 pi I into sum of the residues at the interior poles, here is this one. Here the residue value here is 1 by root 3i and 2 pi by root 3 is the answer. So this is how we have to solve. So if you really understand this one, please practice and get more marks and pass it on to your friends if you really like, and please go through the playlist and so many videos are uploaded for your preparation. Please avail those, and thank you for staying till the end.